Welcome to this fourth part of the AI tutorial, and with this fourth part we're going to work more on the game. So where were we? So if you remember the last time, we basically had this setup. I've moved some nodes around a little bit, but essentially we've got the behavior tree with an idle branch, a branch that moves the character back into position if he's doing nothing else, a branch that looks at if he hears a noise, so essentially goes and investigates a noise, a branch that currently doesn't do what we want, but it will essentially come and attack an enemy if they're seen, and a branch that deals with going back to the position if he gets too far away. So the typical sort of MMO guard setup. So if he goes outside of a given radius, and I've tweaked the radius here to be a bit bigger, it means that this branch will overtake priority over all the others and send him back to the start point. So one of the things that I talked about last time was this fact that before I had the reset enemy stuck off here, the idea being that if we have an enemy, we do something to them and then we reset the fact that we know about them. So essentially we'll run this set of nodes until we're satisfied, essentially, and this will reset the value so that this branch condition won't be true, and it'll stop running this tree, which is fine. So I should have, I guess, a copy of this over here. So that's what we would have had normally before, and we didn't have the way, I don't think. The problem is that this node, as I said before, wasn't actually firing, and that's because essentially this branch was taking over, and when this branch took over, there's no way to sort of catch the fact that this subtree is being subverted. And I had a word with Mishko, who's the guy who's actually doing the AI code for a lot of this stuff, and he said, yeah, that's right, there isn't a way to do that right now. Obviously this is still a work in progress, all of this AI code. I mean, it's actually really good for what it's got so far, but there's still things to fix up. So I'm going to submit a pull request at some point with a fix to this kind of thing, but I haven't figured out which way I prefer the fix to actually work yet. And he said if it goes on the list of stuff to do for the AI, it's probably low priority, doing things like resetting blackboards and what have you. So just be aware that if you've got anything where a higher priority set of nodes takes over from a low priority set of nodes and you need some cleanup, for now, one way of fixing that is to actually do the cleanup. So basically that's just cleaning up a blackboard, is to do the cleanup in the higher priority. So essentially this priority overtakes the nodes from that priority and you do the cleanup here. One thing the smart guys of you might notice is that I'm doing the reset after this priority set's run. If I had another priority set, I probably would have done the reset at the start. But as it is, this is the highest priority subtree. So essentially I know that this subtree will move until this is complete and then run this node. So basically this is complete or fails, and then this node will get run. So I know this is going to happen. It just makes it so I know that it's resets, because otherwise that move to could move me into a position where he actually sees another enemy. So essentially I'm making sure that the enemy's reset at the end of his move back to the guard position, just so he doesn't. Imagine if I'd reset and then moved through the world and I could have seen somebody as I was moving and stored the value back into the blackboard. This way I know the move's complete and then it resets the value, so I know that when it comes back to doing the conditional checks on all of these other nodes, I know that the value will be set back again. That's why it's there. So this video is going to be a little bit different than some of the others, because I've actually prepared some stuff up front, and there's a good reason for this. Is that if I just drag some a playlist from here, we're going to use some stuff from this playlist, which is in the Unreal Engine playlists on YouTube. We're going, I mean, it's basically 22 videos, right? So I don't want to include all of the stuff that you need to do from this playlist, but basically I think it's from number 16 of this tutorial onwards. This goes through setting up things like animation on characters, and what else is there that we're using? Animation states, character setup stuff. So essentially what we're going to use from that is this animation stuff. I will go through it and I'll tell you exactly how I'm using it, but I just wanted to make you sure you can get by without doing a lot of this stuff immediately, but you will have to go through that whole tutorial set if you really want to understand how to do a lot of this. I am not going to show you exactly how all of this works, because it's described very well in Zach's tutorials, so it's really just a matter of pointing you to the right kind of data structures and stuff in mine. So with that said, what we're going to add to this functionality, well, what we want to have, when the enemy is seen, we want to have the character do something, and ideally what we want the character to do is to come up to the enemy that they've seen, so basically move towards them. We want them to do some kind of animation, and we want to perform some kind of attack. And so before we can do that, we probably want to be able to play an animation. That's kind of one of the first things we want to do. So let's have a look through how the character animation setup code is actually used, because there's a couple of things that are kind of complicated here. So I'm just going to pause there, and we'll load back up with the actual animation view. So what you're seeing here is the event graph of the animation setup for the character that we're doing the AI for. It's one of the basic ones. I think it comes from the third-person template. But essentially, if you load up the third-person template, you will probably see this setup in the event graph. So essentially, it handles with is the character in the air or not, those kind of things. Now what we're going to do is we're going to, because we want to play an animation when we set it from the AI, so we're going to have to deal with using a task from the behavior tree. So we want some kind of task from here that kicks off an animation. How are we going to do that? Well, there's two parts of this. If you go back to the blueprint tutorials on YouTube from the Unreal Engine guys, you'll find that there's a thing called the the blueprint interface, and we've created in one of our folders an interface, which is essentially, if you go to click in the folder, let's do it in here, blueprint interface. So if you could create one of those assets, and I've already done one here, the interface essentially gives you a way of defining a set of functions, and the idea is that this set of functions that you can define have to then be implemented by a blueprint for this interface to be valid. So we can add an interface that's not necessarily implemented on all blueprints, and we can query whether the blueprint in question has the interface or not. So think of it like if you're a sort of normal C++ programmer, it's almost like a sort of interface. Well, it is an interface, but essentially it's a set of functions that an object should have implemented for the interface to be valid. And what we've got here is I've just defined one function, which is called playAnim. Now, normally you would do a function with some parameters, and you can add inputs and outputs in these fields here. But essentially, this playAnim is an interface. So any object that can deal with animation should have the playAnim interface implement on it. So if we go to the animation blueprint again, you can see that I've actually got an event here called playAnim. So basically that's using the playAnim interface and creating a custom event handler for it. Now, where does this come from? Because you won't get that by default if you sort of add event, right? It comes from the blueprint properties. If you go to blueprint properties on your animation graph, and you do interfaces, and you can add interfaces. So I've already got this playAnim interface implemented. You know, I can add other ones if I've got other ones. So essentially, this interface functionality it's almost like a sort of pass through between one blueprint and another. So it's in this case it's between my behavior tree task blueprint and my animation blueprint. So what I'm saying is that if I get a call to that playAnim function, I'm going to handle it in this event graph, and I'm going to handle this event and do some logic. So in this logic, what I'm going to do is I'm going to check the variable of this playAttack boolean and say if it's not set, I'm going to set it. So, and this is a good sort of protection from not constantly setting the animation going. And then I'm going to play a montage. And again, from that tutorial set that I talked about, they show you how to set up montages. So I'm just going to say, okay, I'm going to play a montage on the animation graph, and it's going to play my attack montage. So basically, I'm going to get an attack animation. I'm going to blend it by one, so basically the full attack animation is going to be blended on top, and I'm going to bind an event when the montage ends to basically set it to not playing and not blended. So essentially this whole set of code tells it to play a montage when I see this custom event, but only if it's not already playing. So like a sort of playAnim once kind of thing. And that's really quite useful because it means that we can handle an event and just say play a montage on top of our animation. So if you look at the animation graph, and this is exactly what Zach ran through in his tutorial, so I'm not going to talk you through it too much, but essentially it does what Zach says, which is basically blend in some animations for part of the body based on whether it's doing an attack or not. And you might not want to do just a blended thing like I've done. You might want to do a full body attack animation kind of thing, but I wanted to keep it so that the character can run towards you and attack at the same time. And I'll show the attack montage, and it's not the best in the world, to be fair, but you know, it does what it needs to. So the montage itself, again, Zach's tutorial took you through setting up a montage. It's essentially copying a couple of the animations. All I wanted was the arms to do something, because I'm only taking the arm animation from this particular montage. The lower body doesn't do anything and the movement doesn't do anything. So essentially I am just doing an attack animation for the arms, because I only wanted to use stock animations essentially. Ideally you would have a proper like attack of some sort animation and just run that instead of a montage necessarily. So that's the setup for the character. So what we need to do is we need to essentially use this interface. So this interface function, we need to call it somewhere, right? So going back to our behavior tree, what I've done is I've called create new task, and it comes up with the default name, and I've renamed that to something else. And instead of showing you sort of live coding it, I'm just going to show you the final code for this one particular. So the animation itself, this task essentially is going to just call that function via the interface onto the animation blueprint. So there's a few casts that we need to do here. So when we get the execution for this particular task, we're going to essentially get the controller, get the controlled pawn, cast that to a character. So essentially we're getting the character information from whatever we're controlling as our task, and we're going to call a thing called getAnimInstance on that character. So basically the anim instance is the sort of animation blueprint stuff, right? So the graph for all of this stuff. Yeah, so this is the animation blueprint is the animation instance, and we can then call the playAnim function on it. Again, remember we did that playAnim interface and actually handled it in this animation instance and animation blueprint. So it'll get passed through to our animation blueprint, and then we're just going to succeed. So essentially this task calls that playAnim function, and in this case it's handled by the animation blueprint of this character, which is the character we're doing the AI for. So it's a bit of a long-winded process, but it's just making sure that we're getting the correct object and then calling that function. So I'll just take a quick slurp of tea, and then we'll come back and we'll do the final part, which is the attacking part of this. Okay, so we're going to call our task here. We're going to call our playAnimation task. So we're going to move to whatever we've seen. We're going to play the animation for attack. The next thing we want to do is actually do some damage to it, right? Now it just so happens that I've already done a damage task as well. So let's just have a look at that. And it's exposed two properties: one, the thing to damage, and two, the damage amount. So let's just switch those to the enemy we're attacking and say 10. And if I look at the code that I've done for this task node, so you basically just create an empty task and you can add this code to it. When it executes, it checks to see if the blackboard value for our target is valid. So basically, is it a valid object? And then it calls the function apply damage, using us as the sort of damage causer, and it's saying how much based around this variable, the amount of damage to apply. And then it's finishing. So it's essentially a really simple task, right? It's saying get me the blackboard actor, make sure he's valid, apply damage, so using the actor's apply damage method, and then finish. So that's all that task needs to do. So if we go back to our behavior tree, all it needs to do is move. So what we're going to have is a sequence of, if I've seen an enemy, if the enemy's if the enemy is set in the blackboard, we're going to move to him, we're going to play an animation, we're going to do some attack damage. Now this attack damage blueprint node is a default one, sort of works on actors. I think it actually works on the pawn level, but so what we're saying is that it works on most objects, but obviously most objects don't actually do anything with it. So we're going to have to fill in somewhere something to handle the taking damage. So this is just going to cause the damage to be executed. So if we go back to our behavior tree and just save that. So what we need to do is we need to have something that responds to damage, right? And essentially in this test condition, the thing that's going to respond to damage is actually my character, the character that I'm controlling. It just happens to be called my character. So if you remember last time I had an F key thing that made a noise. This is just your standard character blueprint, right? So you can do whatever you like in here. But the interesting bit really is that you can, if you look at the sort of events, one of the events that you can handle for characters is event any damage, point damage, radial damage. Well, we added an event any damage here, and what essentially it's doing is it's taking the damage value that's being passed to it and subtracting it from the current health value. So there's a publicly available float value for health, and it's subtracting the current damage from that health. It's doing a maximum of those and 0, so basically it doesn't go below 0. It's setting that health value. So essentially this health value then has our current health, and we'd probably want to do some logic off here that says if it goes to 0 or below, then we kill off the character or whatever. But in this case I'm just making sure that it prints the actual value. Now I don't know whether you guys have gotten that far yet, but essentially there is a new user interface system for 4.5 coming along, and I'm using 4.4 right now. So this interface is experimental, and so I'll probably just talk you through what I've done to set that up, but this setup probably will change in the future. So I don't want to dwell on it too long, but so basically this node is the way you handle damage. So we've called the damage from our attack behavior tree task, and this is the thing that handles it. And we should probably do some more logic in terms of actually killing the character or whatever else. But for now, I just wanted to make sure that we can actually do some damage and handle the damage that's being taken. So I wanted to create a sort of widget that shows the health bar, and in this case we get another, we need to initialize our widget, and for this particular player character, this is the character I'm controlling as a player, right? So we can handle it in event begin play. We can do the create widget, and I'll show you the widget setup in a second. But basically what it does is it creates the widget, sets it into a widget actor variable, adds it to the viewport. So it adds the widget that we've just created to the viewport, casts it to a particular kind of widget so that we know that its properties, and then sets the property in the widget to display our health. So that's what it does to initialize. And then obviously once we've got that initialized widget, we can check to see if it's valid in our update. So after we've done the print string thing for handling our event damage, we can actually just keep continuing to check our widget to see if it's valid, cast it to the particular type of widget again, and then set its value in the health. So essentially every time we take damage, we update the user interface for it. So going into the widget itself, widgets have so this is a progress bar that I've added to the widget designer, So if you go to here, you can create a user interface widget blueprint. And what I've done is I've created a widget blueprint, and it's called IG car info. When I go into it, I've dragged a progress bar in from the progress bar here, and I've when I click on it, I've added a function called get health. Basically it says bind here, and I've clicked on the bind thing. And what this get health function does, so when it loads up your graph when you click on the bind, is it's expected to get the value to fill in from the progress bar. Now it just happens that the health to display that I've added as a variable, this health to display is actually in our 0 to 100 range from our health value, and the widget itself requires it in 0 to 1. So all I do is divide by 100 essentially to get it into the right scale of our widget display, and then return it. So when you come to create the binding, it will give you these two nodes, and I've just used my variables. So essentially I've got a variable that I added called health to display, and I can set that health to display from my interface. So essentially when it's calling the attack, it's calling this apply damage function. The character itself is receiving that apply damage event and setting its own health value. It then calls set health to display, which is this variable here, and when this variable gets changed by that set health to display, and then when the user interface gets drawn, it calls this get health function to give it the value, and health to display is divided by 100 and returned as the value to draw the progress bar with. So what we should get is, if we run this, you'll see that the health bar starts off as full, and if I so essentially he can run after me now and keep doing damage. I can run out of his range and he runs back to his starting point. So you can obviously see we'd fill in things like, you know, some kind of death when he dies and sort of kills him off and those kind of things. So I guess that's the next part of the tutorial, is that we're going to handle the event for when he dies. We need to sort out so when my character dies, something needs to happen. Maybe we need to respawn the character or something. We need to handle in the behavior tree what happens when am I just too far away from this? Am I? So he's doing that sort of it's a crappy montage, but it's basically just so I could see whether there was an anime playing or not. So there are a few edge cases. So we don't currently have a case for when the character dies, like what happens to the AI. The AI should essentially get its blackboard variable set back to empty or null so that it doesn't run that attack tree. So that's where we'll leave it, I think, for this one. Relatively short one, but there's a lot of stuff to look at there, and I want you to go and have a look at Zach's setup tutorials for the animation side of things, and you might want to have a look at how the current UMG user interface setup's done and the data binding for that. There's a whole bunch of stuff on the Unreal Engine document page that I think you need to review. And we'll call it a day there. So we'll finish off the guards in the next video. Thanks for watching.